Welcome to Isle Delfino! The end goal of Super Mario Sunshine, as in most Mario games, is to rescue Princess Peach, who has been kidnapped. During this quest, you are tasked with recovering Shine Sprites, the source of power for Isle Delfino. Throughout the game, there are 120 unique Shine Sprites to collect throughout 10 different areas. These 120 shines, which we will call the Super Mario Sunshine, or SMS shines, resemble a set, an unordered collection of distinct objects. The different areas in which you can collect shines are Bianco Hills, Rico Harbor, Gelato Beach, Serena Beach, Pinna Park, Noki Bay, Pianta Village, Delfino Plaza, Delfino Airstrip, and Corona Mountain. These areas are subsequently subsets of the set of SMS shines. This means that each area has a number of shines that are part of the total 120 shines in the game. Let's take a look at one of these subsets, Serena Beach. Serena Beach has 8 episodes. 6 of them have 1 shine to collect, and 2 of them have 2 shines to collect. Then, there's an extra shine that can be obtained by collecting 100 coins in any of the episodes. Therefore, we don't technically count it as its own separate episode. We can look at 2 sets. The superset, in this case the episode in Serena Beach, is called the domain, and the subset, the shines that you can collect in Serena Beach, is called the codomain. Because you have to visit Serena Beach episode 2 and 4 twice instead of once, this is a total surjective relation. Each element in the domain has at least 1 arrow to an element in the codomain, and each element in the codomain has at least 1 arrow from the domain. Because episodes 2 and 4 have 2 arrows out and are matched with more than 1 shine in the codomain. In contrast, in Corona Mountain, since there's only a single shine to collect, this represents an injective function. Each element has 1 or less arrows to an element in the codomain, and each element in the codomain has 1 or less arrows from the domain. Therefore, the one episode in the domain is matched with 1 or less shines in the codomain in this example. The relations between sets can be indicative of the size of the set, known as the cardinality of a set. For example, the cardinality of the Gelato Beach set would be 11 because there are 11 shines to collect. In a surjective relation like Serena Beach, the cardinality of the codomain will be greater than the cardinality of the domain since there are 11 shines but only 8 episodes. In an injective relation, the opposite would be true. Essentially, this graphic reverse will be injective, and thus the size of the codomain will be smaller than that of the domain. In a bijection like Corona Mountain, the cardinality of the codomain and the domain would be equal because there is exactly 1 episode and exactly 1 shine to collect. The first set operation we will look at is intersections. An intersection is where the element is part of 2 different sets and is indicated by the use of AND. While there is not an example in Super Mario Sunshine, hypothetically, if we consider the shines that are obtained by defeating Shadow Mario in each area during episode 7 as the same, then Bianco Hill and Pianta Village would be equal to the set consisting of the 2 shines you collect from defeating Shadow Mario. The next set operation is unions. A union is where the element is part of at least one of the different sets and is indicated by the use of OR. If we consider the Bianco Hill and Pianta Village sets again, Bianco Hill or Pianta Village would be equal to the set consisting of all the shines from both Bianco Hills and Pianta Village, because those shines are part of either the Bianco Hills or Pianta Village sets. The final set operation is complements, where the element is part of the universe, what we consider to be the collection of everything in consideration, but not part of the set in question. In this case, the universe is the set of all the SMS shines. And for example, let's look at the complement of Pinna Park. The complement would be everything that is part of the SMS shine set, but is not a part of the Pinna Park set. Thus, the complement would be the part that is not green in this diagram, all the other sets within the SMS shine set, as none of these shines are also in the Pinna Park set. The power set of a set is the collection of all the subsets of the set. In our case, we will look at the power set of the set of SMS shines. The subsets are all of the areas, so the power set would be the set of all those sets.